Thank you. Welcome everyone to this second session of the ACAN Carbon Clinics, debugging WLCAs. Just for some housekeeping, you have seen that we've just started a recording. This is a recording of just the first session where we're going to have presentations. In the second session, where we will follow with a Q&A, we will be off record. And the recording will go on YouTube after we complete. I am Aliki, and I'm joined today by the fellow Embodied Carbon Working Group in ACAN, who are with us this evening, Mariana, Jonathan, and Devi. We represent ACAN, who are a network of individuals within architecture and the related built environment professionals, taking action to address the twin crises of climate and ecological breakdown. As you can see on the screen, our mission is to mobilize a new movement of professional activists towards this goal by building an open, supportive, and inclusive organization. ACAN empowers individuals to proactively seek change and facilitates collective effort through a shared platform built on collaboration. We've got three aims. First, to decarbonize now. We seek to radically transform the regulatory, economic, and cultural landscape in which our built environment is made, operated, and renewed in order to facilitate rapid decarbonization of the built environment. Secondly, second aim is to achieve ecological regeneration by immediate adoption of regenerative and ecological principles within the built environment and society. And third aim, to spark cultural transformation. We call for a complete remodeling of our professional culture by challenging and redefining the value systems at the heart of our industry and education system. And we are looking to do this by creating an open and sharing network, which is what brings us here today. So today is the second session of our recently launched campaign called Carbon Clinics. Through this campaign, we are bringing together industry experts who will share their knowledge, experience, and woes in the adoption and implementation of conducting whole life cycle assessments in their respective organizations. The aim of the campaign is to bring practical insights and foster greater dialogue between us during the process and towards better standards and consistency in this world of WLCAs. You can find the previous introductory session in our YouTube channel online, where we will also be posting all sessions of this campaign, including this one today. Here is some of the topics that we are hoping to discuss in the coming sessions throughout the year. Feel free to suggest any topics that you would like to hear about or present yourselves as part of this. And for this, we would like to ask you to fill in the poll that you see in the screen now, access to this QR link. And this poll will help us identify together the burning questions that you may have and formulate the content of this campaign. I'll give it a few seconds before passing on to Devi, who will introduce the topic and the presenters of today's session. The topic that we will be discussing is titled Data Collection Methods and Whole Life Cycle Assessment Inputs. And we will dig into how to use various data collection methods and data sources to enable WLCA inputs, both when it comes to project data and carbon data. Devi, off to you.
Thanks, Liki. Yes, so the idea behind this series was there's quite a lot of resources out there covering the theory around whole life and embodied carbon, but we wanted to really have more of a kind of practical guidance on how to apply it in real time and in real projects. The approach varies slightly between early stage and detailed stage. Therefore, that's why we've split it into two speakers today, one Paridi covering the early stage and Matthew covering the detailed and construction stages. So they'll each present for about 30 minutes, followed by a Q&A, which will be facilitated by Jonathan. But in the meantime, feel free to drop any questions in the chat if they come to you during the presentations, and we can use them at the end. So Paridi is a sustainability designer at Hawkins Brown, where she brings over 6 years of experience in the field of sustainability. With a background in architecture, she holds a master's in environmental design engineering from UCL And her career spans roles both as an LCA consultant in a multi-disc company and also working in-house in architectural firms. For the past few years, she's focused exclusively on conducting LCAs at all RBA stages, from early design through to post-completion. And her expertise is in integrating sustainable practices throughout the design process, ensuring environmental impact is minimized at every project stage. And Matthew is an associate director and UK group lead for Whole Life Carbon at Sweco, a multi-disc engineering and design consultancy with roots in the Nordics. Matthew has worked at Sweco for 11 years, focusing specifically on whole life carbon and embodied carbon for the last 8 years, building and leading Sweco's WLC team. With a focus on large-scale commercial and residential developments, Matthew has led on sustainability for some of London's more forward-thinking schemes, including 105 Victoria Street, 2 Aldermanbury Square, and multiple sites within the King's Cross master plan. He also is a keen contributor to industry initiatives and work streams, having contributed to or led work streams for the UK GBC Net Zero Roadmap, their embodied carbon modelling and reporting work stream, working as a third-party Q&A for City of London's carbon options guidance submissions, and more recently developing the exam content for CIBSE's forthcoming Whole Life Carbon Assessor training course. So without further ado, I'll pass the baton on to Preeti to talk about inputs at the early design stages. Thank you.
Thank you, Devi. Good evening, everyone, and thank you for joining today's session. My name is Paridhi, and I'm a sustainability designer at Hawkins Brown, and I'm delighted to be here to discuss how we can achieve low carbon outcomes in the early design phase. Next slide, please. So let's start by looking at some of the key things that help deliver a low carbon design. The most important takeaway, it's a team effort. Delivering low carbon design requires collaboration and engagement from all stakeholders. It's really helpful to have a client-side representative working closely with the sustainability team. Together, they can make sure that the project team stays aligned and on track to meet key carbon performance goals. Next slide, please. The earlier we start thinking about carbon, the better. At the beginning of the project, we have fewer details and make a lot of assumptions. But this is also when we have the most flexibility to reduce whole life carbon. As the project moves forward, we get more accurate data on materials and specifications. But by then, big decisions like the structure and layout are already locked in. So it's crucial to act early. Next slide, please. At the start of the project, the largest carbon savings can be made through optimizing the brief. So we start with build nothing. Do we need to build something at all? Build less. Is the brief spatially efficient? Can we use a building or a material that already exists? Is the proposal refined enough? Build light. Can we reduce the material volumes by adjusting structural loadings or grid sizes? Build wise. Can we minimize materials, balance upfront carbon impact with longer-term replacements? Build low carbon. Have we discussed and chosen a low carbon material palette? Build collaboratively. Ensure the whole team is involved in designing, delivering, and operating a low-carbon building. Share information openly and be transparent. Next slide, please. The best practice WLCA process should be integrated into project and cost planning from the beginning rather than waiting for a final report. Teams should use WLC data at key decision points. Running a partial WLCA early, just for structural options, for example, helps compare materials and designs before making big commitments. The earlier we assess, the more opportunities we have to make meaningful carbon reductions. Next slide, please. Before we start measuring any of the material quantities, we need to get a few things straight. So what is our project scope? Is it a new build, retrofit, or a master plan? What are the building details? What's the GIA? How big is the facade? How many floors are there in the building? Then what are the team roles? Who is providing what data? What are the material specifications? What do we already know and what's still an assumption? Standardized measurement units. So consistency is very crucial. For example, if the steel quantities are measured in tons, that unit should be used throughout the project to maintain the data integrity. Next slide, please. Before we can calculate carbon impacts, we need to define a few boundaries. Are we measuring upfront embodied carbon or whole life carbon? Which data sources are we using? Is it generic or is it manufacturer specific? What units are the carbon factors in? Because having that consistency is key. And don't worry if these terms sound a bit technical at the moment. We'll go over them in more detail shortly. Next slide, please. So the whole life carbon assessment process follows a structural methodology aligned with RICS professional standard second edition. So as you can see here, we have the first step, which is the initial assessment, which defines a project and project scope and identity. Then we go to step 2, which is collating the project information, be it via project BIM model or BOQ or cost plans. Then we go to components, inventory, and energy sources, and listing the quantities. Then there's assessment of the project till the completion. And from there, that's when we start with our carbon assessment from modules A0 to A to C. And after that, we have the step 7, which is reporting. Next slide, please. So how do we set carbon targets? There are several industry guides we can use for benchmarking. REBA 2030 Climate Challenge sets out targets, actions, and methodologies. LETI provides detailed guidance on low carbon design, and we now also have UKN ZCBS, which is the newest standard. These documents give us a good starting point for setting performance expectations. Next slide, please. And now we'll discuss the initial consideration before conducting an LCA. Next slide. The project lifecycle stages outlined in the RICS Professional Standard Second Edition are based on the modular structure established in standards such as EN 15978. I'll delve deeper into this module in the upcoming slides. Next one, please. So as the project progresses, our WLC estimates become more refined. During the early design phase, A to C are largely based on assumptions. As the project progresses, the information becomes more refined, and by the construction phase, you have actual data for A1 to A5 and so on. Next slide, please. All buildings are made up of different elements, so substructure, superstructure, facades, services, finishes. As the design progresses, we get more detailed material breakdowns. By practical completion, we have the most granular data, as you can see in the table on the right. Next, please. Looking at this LETI pie chart, we can see that the biggest contributor to the building's embodied carbon is usually the superstructure, which includes primary frame, facade, internal assemblies, and roof. That's why early decisions about structural systems are so important. The percentage of these categories change depending on the building use, so it's important to refer to the appropriate benchmarks. Next, please. The reference study period. So it is the time frame we use to assess the in-use emissions while the building is in use. In the UK, the standard is usually 60 years, but in some European countries, it's also 50 years. So be careful when you're comparing international data. For UK, as per RICS, the typical RSPs are mentioned here. So the building, it's 60 years. For standalone fit-out or temporary projects, it's 20 to 60 years. And for infrastructure projects, it's 120 years. Next, please. So when collecting material quantities, BIM models, BOQs, and RFIs are the key data sources. We'll go into more detail about these in the upcoming slides. Next, please. So if there's an existing building on site, and it's important to take this into account as early as possible and try to get hold of some as-built quantities. You should talk to your project manager or client and get the pre-demolition audit commissioned, as this will give you fairly accurate representation of the material quantity and specification, and will also be useful for any circular economy assessments you may need to do, if it's GLA referable, for example. Next, please. In an early stage assessment, we don't have all the details yet. So RICS accounts for this by adding a 15% buffer during the early stage assessments. As the design progresses, this uncertainty changes, and it is refined by focusing on the top 10 most carbon-intensive materials. Next, please. So another key aspect of calculating carbon is the use of databases, which fall into two categories: generic, like IC, and supplier-specific, like the EPDs. Next, please. So the generic data is material-based. It's not product-based, and so is preferable to use at the early design stages. The commonly used free and generic database is the ICE, that is Inventory of Carbon and Energy by Circular Ecology. This gives us the data for A1 to A3 only, which is just the manufacturing of the material. Next, please. So yeah, when carrying out these EPDs, so when carrying out the LCA, environmental product declarations or EPDs are the key sources of data. There are a few different types of EPDs, which with each different levels of specificity. First, we have the collective EPDs, which are industry-wide and represent an average across multiple manufacturers. These are useful in early stage assessments when you haven't yet specified a particular product, but need a general understanding of material impacts. Then there are manufacturer-specific EPDs, which provide a data for a particular brand, but may still cover a range of similar products rather than a single one. Finally, the product-specific EPDs are the most detailed, covering a specific product from a specific manufacturer. These are most relevant at the later stages when you've made a final material selection and need the most accurate carbon data for your LCA. Next, please. These EPDs must be third-party verified and comply with EN 15804 standards. Some companies may not produce EPDs for every product in their range, so you may need to use the closest equivalent account for uncertainty in the early stages. Next slide, please. So EPDs can also be classified as A1 and A2. A1 EPDs typically cover only A1 to A3, requiring assumptions for the other life cycle stages, while A2 EPDs include more indicators and cover all life cycle stages, and they have been in circulation since 2022. Next, please. When reviewing your EPD, we need to focus on the GWP. Even if the EPD includes A to C data, it's important that we consider the RICS default figures for early stages, as RICS has its own methodology and assumptions. Ensure that the declared units are aligned, and remember that EPDs usually are harder to obtain, so we have to talk to the manufacturers and be in touch. These on the right side are a couple of resources that can be used to understand how we can read EPDs. Next, please. So here are the few databases on the left that provide easy access to general material information if you don't have the EPDs. And on the right, you can see that there's a material pyramid that was created by the Royal Danish Academy. So this is very useful as you can compare many different materials on the screen on one screen. And it usually you can switch the units, and here it is based on GWP per meter cube. Next, please. So now we'll talk about early design phase inputs. Next, please. So at the early stage, it is very important that we define the purpose of the assessment and conduct an optioneering analysis, which is quick preliminary calculations about considerations that we make during early stages, like typical structural base. And we need to be aware of the material carbon hotspots and identify the key areas that could have probably higher carbon impact. So we can start creating carbon reduction strategies accordingly during the early stage. Next slide, please. So before we start the analysis, it's important to understand how we collect the data. The most common methods are RFI forms, which are the request for information forms, which I will go into more detail in the next slide. They provide, and then we have the Revit model, which provides detailed material quantities or takeoffs, usually in a spreadsheet format. The main advantage of using a Revit model is that it gives you precise quantities based on the actual model. However, if the model's components or assemblies are not accurate, the quantities might not reflect the real requirements. So that's why it's very crucial to cross-check the data with the BOQs for accuracy. BOQs or cost plans. So when using these, ensure that all quantities align with the units that you've assigned, as having that consistency in the units is very crucial. And always review carefully and ask questions if needed, and go back to the BOQ consultant. Also consider the recycled content. Concrete and steel often usually have some, and the specification for that should be noted. And all of these are can be interrelated. So you can always cross-verify any information that you've received from your Revit model with the BOQs or with the RFI forms, or even with the drawing specifications that you have. Next slide, please. So this is an example of an RFI we use here at Hawkins Brown. So an RFI can be issued to gather quantities from the relevant consultants. So you need to first identify consultants, usually the design team, landscape, MEP, structural and civil engineers, determine the specific information needed for the analysis, including the data structure and preferred units. Establish the deadline for receiving the information to ensure that the analysis can begin according to the project's timeline. Next, please. So at this stage, typically only structural strategies or facade buildups are available. So typical base studies for horizontal and vertical grids should be conducted at concept stage for different material arrangements to determine the impact of the total embodied carbon for each framing arrangement. Next, please. So here you can see a typical office breakdown showing the impact of each element category. The facade has a significant impact, making it one of the elements that should be addressed early in the design phase. This highlights the importance of making conscious choices for facade elements from the outset. Next, please. So now let's look at this case study, Golden Lane. It's a major office retrofit near Barbican. The project keeps 96% of the structure while adding 4 stories, all without foundation strengthening. The client committed to sustainability and wants it recognized as net zero under the UK GBC framework. I want to show you this to demonstrate the importance of delving a bit deeper into systems at this stage. Next, please. So now here we are looking at the. We were looking with the architects at a few cladding options. We expect a GRC to have lower emissions than aluminum. However, once we factored the steel support structure, the carbon impact was almost the same. This was mostly because although our GRC itself is low carbon and lasts long time, the proposed buildup required a lot of steel framing to hold it up. Next, please. So when we look at the material breakdown here, the steel supports for the GRC stand out as the biggest carbon contributor. So if we had reduced the amount of steel or ensured it came from recycled sources, the GRC would have had lower carbon impact from the aluminum one. Next, please. So here you can see that making assumptions, how we can make assumptions using benchmarks. So key assumptions that are needed for internal finishes, services, FF&E, or external works even. So we can use industry benchmarks that are already available, GLA, BECD, or past projects or team expertise, whatever is easily available. The step 1 is that you source that benchmark impact per meter square GIA from whatever benchmarks you have. And step 2 is you work out that carbon impact of the element separately for each module by multiplying the benchmark impact, as mentioned here at the bottom, multiplying the benchmark impact by the area of the system, and then dividing it by the floor area, that is the GIA. So, and that way you can sort of assume the total carbon impact of that system. Next slide, please. So the embodied carbon of MEP is also quite challenging to estimate at an early stage. So if you think about there are thousands of components in a building. There are documents like CIBSI TM65, which help with measurements, and also the RICS MEP takeoff spreadsheet. You need to engage with your building services engineer early and maybe use some simple rules of thumb to practically reduce carbon. So if you have like naturally ventilated buildings, there's naturally naturally less materials used. So think about simplicity of the plan and try to limit duct runs generally. Next slide, please. So A1 to A3, as you may know, is the product stage. That includes raw material extraction, supply, and manufacturing. RICS has a lot of useful guidance to help with early stage assessments. It helps to fill the gaps with assumptions. Quite often, you won't have the specification for a lot of your materials just yet. So there's a default specification of materials that covers things like precast concrete, steel, timber, MEP products, facade buildups, and a lot more. Next slide, please. So the A4 module measures the emissions from the transport of goods from the factory to the site. So the data you need to put into your tools is normally the vehicle type and the distance traveled. So again, RICS has early stage assumptions that you can use here, as you can see in the table on the right. Next one, please. So the A5 module is the emissions from the works on the site during construction. As per RICS version 2, it is divided into A5.1, which applies to deconstruction or demolition on the existing building asset. So if actual figures are not available, a standard assumption for the UK of 35 kilograms CO2 per meter square should be adopted. And for A5.2, which is construction activity impacts that include impacts from any construction activities and installation processes on site. So as per RICS, the baseline impacts for UK should be estimated at 40 kilograms CO2 per meter square GIA. Similarly, A5.3 is waste management on site, and the default figures for as per RICS are in this table, as you can see. Next slide, please. So the B1 and B5 stages cover the in-use phase of the building, including its use, maintenance, repair, replacement, and refurbishment throughout its lifespan. So default scenarios should be applied with a focus on modules B1 and B4. B1, which addresses the impacts of refrigerants, often has a very high environmental impact and requires early stage discussions with the MEP team. Various reduction strategies can be employed, such as stacking plans to minimize ductwork. But this is something that requires an early stage inputs from the MEP consultants as well. Next slide, please. B4 covers material replacement, which can have a very big impact, especially if certain materials don't last long. That's why predicting how long the materials will last is also important when calculating replacements throughout a building's lifespan. And RICS gives us the default figures and guidance for each material's lifespan, as you can see in the table on the right. Next, please. So at an early stage, you may not have the model for operational emissions. And so you have to start consulting your building services engineer. As design progresses, use predictive energy modeling, which is like TM54 or Passive House, for operational emissions, and not a compliance models like Part L, which overlook non-regulated energy, like the energy from TVs and fridges, etc. CIBSE TM54 calculations may not be available early on, but benchmarks like NZCBS can be used. Just ensure, though, that you align the expected performance with the engineering team, because it's a best practice benchmark, and not every consultancy would be, not every engineering team would probably be going forward with this. Next, please. So for B7, benchmarks such as REBA 2030 or any other relevant benchmarking standards can be applied. Also, there are carbon conversion factors which can be used from the UK government, which are mentioned on the right, if the local board does not provide a figure. Next, please. So at the end of the building life, materials are either getting reused, recycled, or sent to landfill. So the table here outlines the end-of-life processes as per RICS and the different routes for each processes and the corresponding life cycle modules and their outputs. Next, please. Yeah. So with this, we have come to an end of the early design phase inputs. And to conclude what I discussed, first one is think why you're doing the assessment, reporting purposes or driving down specific building elements. Start early. The best time to make carbon savings is before any major design decisions are logged in. It's important for you to figure out the hotspots and focus on what you can reduce. Use benchmarks for setting targets. For default assumptions at early stage, RICS is your Bible. Focus on key carbon drivers like structure and facades and MEP systems, which have a massive impact. And lastly, collaborate. Carbon reduction is a team effort, not just the job of sustainability consultants. Thank you. And now on to Matthew.
Thanks, Rudy. Yeah, I was just going to call. Thanks for that. Really insightful stuff. And Matt, I'll pass on to you.
Perfect. Thank you very much. Hopefully everyone can hear me fine. Thank you very much for having me along to this session. It's a pleasure to be able to talk to you about the work we've been doing on pre-construction and post-construction whole life carbon assessments. On to the next slide, please. So welcome to the Wild West of whole life carbon, where the rules go out the window and is very, very difficult phase of getting information, establishing what your final position is. There are very few rules and regulations to this stage. So I just wanted to talk you through what we've been doing at SWECO over the last sort of 5 or 6 years to really get to the bottom of this and understand how we navigate through the late design and construction stage processes to get to the answer we want at the end of the project. Next slide, please. So Paridi has talked quite a lot about the assumptions and the information that you use during the early stage whole life carbon assessments. But of course, when you come to construction, you're wanting to use actual information from the project, from the actual products and systems that you're using in the building. And it's really important that we do post-construction whole life carbon assessments for validation purposes. Wherever we set a design needs to be validated at construction with the actual products and materials that go into the buildings that we construct. The big question, though, is what actual advice is there out there that helps us to really understand and implement on a strategic basis the undertaking of whole life carbon assessments at construction stage? And we'll have a quick look at that now on the next slide. So Paridi has introduced us to RICS, the framework, the elements that we talk about and look at. But when you're looking at the construction phase, all you've really got is a couple of statements. We expect you to do a construction phase and a post-completion stage whole life carbon assessments. You are expected to use this type of information to deliver this assessment at this stage. Not especially helpful when it comes to actually conducting one and navigating through the construction process. On the next slide, what we'll also see is the GLA. So the GLA do very similar thing. When do you need to submit a whole life carbon assessment? Well, you need to submit one at post-construction, not how you do it. But we also see drivers from planning, right? There's a recent City of London project, just an example there on the right-hand side at the bottom, where there are conditions associated with undertaking and doing whole life carbon assessments. So really, that's the extent of it. Those are the requirements to do and undertake whole life carbon assessments at post-construction. But there's no real gauge of what do you actually do? How do you collate that data in the first place? What are the methods and processes you have to go through? How do you engage with contractors? How do you physically get that information? And it is, in my experience, daunting and extremely difficult to gather that information, particularly with an educational piece around whole life carbon. We, as designers, architects, engineers, we seem to have got to grips with this, particularly kind of in the London nucleus. But within the construction world, particularly within the trades and the subcontractors, it's very, very difficult and problematic often to get this information because the level of education is not there in what needs to be provided. They don't understand RICS, they don't understand kind of the elemental breakdowns of carbon. So I'll talk to you in a bit about the kind of language change that we kind of expect and how we navigate that process. Next slide, please. Preparing for this is really, really important. One of the things that we do at SWECO is early on, we were accountants. We were doing accountancy exercises. We were doing a carbon assessment, providing our clients with reports. We then moved into consultancy where we kind of understood what the key drivers were, where the big impactors were, and how you go about delivering low carbon opportunities within different building elements and systems. We've moved into a phase now where most of our work is carbon project management. Understanding what you do and when you do it at specific project stages is so important. And that is never more important than when you're preparing for a construction stage assessment. The things you do in the build up to that, the level of engagement you have, the things people you talk to, the information you gather is so important in the setup process and delivery and getting the right outcomes at the end. And that really starts as early as REBA stage 3 for the preparation of this type of works, where we kind of look at cohesive specifications. And that's one thing I'm going to talk to you particularly about today. Next slide, please. So this is an example from 2 Aldermanbury Square. And what I mean by cohesive specification is having the conversations. And so much of this is not about technical skills, it's more about softer skills. How integrated is your carbon information? What are your targets? How are those project targets reflected in project specifications? How are the things you've said and agreed with your client, with the project engineers, with the architects reflected in your specifications, right? Because the specification documents are often the documents that are provided as part of any tender process, their expectations and requirements for the contractor to provide information. Yes, you can obviously submit a whole life carbon assessment as part of that. They can read your whole life carbon assessment, but cohesive and back-to-back specifications on expectation are particularly at stage 3 is very important when you're entering a tendering process. And you can see on the right-hand side here at 2 Manbury Square, which is a large commercial 43,000 square meter commercial office development in the city, the targets that we had in our carbon report were reflected within the specification, the expectations that we'd had and agreed with the client and done our early kind of supply chain engagement were reflected in the specification. But it's not just about having that reflected in the specification, it's about cohesive across the whole suite of documents that would be presented or provided. And on the next slide, we can see another example of that, where this is a different type of specification. This is the concrete specification, where that's back to back with the assumptions that were within our carbon report, but it's also reflected in the specification and it tells them what they expected to achieve in the concrete specs. And on the right-hand side, you can see an example of facade performance. So within Arup's facade performance specification, they specified a specific type of aluminium that was expected, and critically, the cost plan is back to back with that, right? So when you're doing these things and when you're making these assumptions and reductions and saying, yes, we're going to procure X material, Y material, having your costs back to back with that is also a really important thing to have, because it means that that's accounted for within your overall project. So this cohesion of specification is so important, and so often on projects that I see, the whole life carbon assessment kind of sits outside as kind of like a boundary element. It's just another document to read in the overall piece, and it's not, there's no cohesion between the documentation that you provide, and therefore the contractor will also see that often as a side piece. It's a separate measure. It's something that is a nice to have rather than something that's ingrained within the project approach, and each part of the project talks to one another. So this part of the setup is really, really important for getting the right answer when you come to the contractor phase. On the next slide, please. So when I talk about there being no rules, I mean that. There's no real documentation out there to tell you exactly how you're supposed to navigate the process all the way from stage 3 specification through tendering, through appointment, how those things are then split down with the trades, and we'll talk a bit about that on the next slide, and then how those requirements are distributed to the trades. Now, so from REBA stage 3, when you come to the main contractor tender, you've got to look at the overall targets, how that target is in. We do a lot of work now of how do you make a target contractual? What are the obligations on the contractor to ensure that that target is met? How do you then manage that with the trades? Do they have their own separate sub-targets? How does that go about? How do you navigate moving from design speak into construction speak? And for the next slide, that is the most important thing I will talk to you about today. It's this changing of language between design and construction. If you go to a contractor or subcontractor and start talking to them about building elements and how your carbon is distributed between building elements, they'll look at you like you're speaking in a foreign language, frankly. They do not speak in that language. The most important thing that we've done at SWECO in the last 5 years for construction whole life carbon assessments is navigating the language change between design and construction. And what I mean by that is what we do with our design stage models is we take that design stage model and we port the carbon emissions from each of those building elements that you see on the left-hand side into construction packages. Each construction package is therefore assigned to a trade or a number of trades, and they each then have their own carbon budget. But more importantly, they know what materials and what products are associated within our carbon model associated with that package. And that process of review has completely changed the game for us in terms of navigating the construction stage and whole life carbon, because now they understand what they're assigned. They understand what's in their package. You can see at the bottom that the overall number of intensity is the same, right? It's just a different way of navigating and setting out how that carbon is distributed within this building, but in a way that actually speaks to the way that construction is done, rather than the RIC speak, because the RIC speak, they don't understand, and therefore taking it into packages is the game changer for us in terms of having the control, firstly, for the client. They understand what the various targets are, but also the educational understanding for the trades of what they're responsible for and how they can physically look at that information and provide it back to us. And that's been the real changer for us with this. Next slide, please. Of course, there are other ways of doing this. That's a typical process that I've shown you before, where a contractor, gets involved sort of in a PCSA at stage 4. We look at their CSA, we port that into construction packages, and we move on into construction from there. But 105 Victoria Street, which is a large-scale 60,000 square metre commercial office building in Westminster, their strapline was always find alternative. And we did things slightly different on this project. I think it's still the only project where I've done it this way. But on this project, Skanska were involved with the design team at the start of REBA Stage 2. Therefore, that level of involvement, interrogation, supply chain knowledge, contact with the supply chain and information was there from the start. So by the time we got to REBA Stage 3, we were already doing kind of post-baseline whole life carbon supply chain interrogation and getting that towards a point where in our Stage 4 model, which you can see on the next slide, please, we already had information. And this is just one example of BDL for the dry lining. And that's the level of detail. It's not just having the big structures, the facades, but we had lots and lots of information at Stage 4 before we went into construction from the trades themselves. And that way we could look at opportunities within each trade, as well as just looking at what the carbon was. We could compare that with our Stage 3 models. But we could also look and investigate opportunities much earlier in the overall design. There were pros and cons to that. Having a contractor on board much earlier, obviously the whole process became much more contractual. The actual level of information we got, trades changed from one to another as we got sort of into the procurement phase of the projects. So it wasn't a silver bullet. What it meant was that our client had an extremely good understanding of the spec and also the input from the trades and how we would control the input and the feedback and the provision of information as we moved into the construction phase. And ultimately, what it meant was the level of comfort we had in our carbon model at this stage of the process was extraordinary, beyond any other project that we've worked on to date. So that is a potential alternative way of navigating whole life carbon assessments, not for everyone. And this is a one-off example in my portfolio at the moment, but an interesting, I think, observation of how you can get better data before you even start the construction stage process and integrate that with trades and contractors. Next slide, please. One of the other things that's really important, I think, to note is that there's a tendency, I think, to send out trackers and pro formas and try and get information and gather information for whole life carbon assessments. The thing that I've found, particularly with the trades, is that there is no one size fits all to gathering information from trade contractors. It's much better to have bespoke trade by trade templates. And we've done that by learning from what is the type of information they provide? How does their procurement process work? How do they gather information themselves internally? And each trade is different. Most industries are kind of similar. If you look at the steel industry, most of the big contractors, Hares, Severs, they provide information in a relatively similar way. But working with the grain rather than against the grain is always a really, really good way of gathering information. How do you usually provide this information? How can we work with you to determine and build a tracker or a document that gets your information from you in the right way? And that's a much better way of also engaging people in the overall process, making them seem like, it's not a black box, gather any information, they don't understand what they're doing. If you work it in with how they typically work, that's generally a really good way of gathering information and getting feedback. And that's kind of basic stuff. It's not rocket science to do that. On to the next slide, please. So a couple of bespoke templates. This is an example of concrete. And this is a good example because generally speaking, in the earlier days, you would send out, this is the amount of concrete in my building. This is the kind of like strength grade C3240, C4050, et cetera, that you would have in your building. This is the quantity that we've used, and these are the carbon factors. But actually, what came back was we weren't getting information in good time. We didn't understand how we were performing against how much concrete we were in our building. We weren't capturing variations. For example, on 2 Aldermanbury Square, we had to do a huge amount more backfilling than we had in design. We didn't want that to occur and just arrive at practical completion. They said, oh, there's 300-400 more cubic meters of concrete in your building. So what we decided to implement instead was a pour tracker. So every time they did a pour, and you will start from the left-hand side of this, they registered that pour, where it was located, what type of mix they had. All those mixes were kind of vetted before we went in. We checked the carbon, what they planned to use as the type of mix, what they then actually used, and each mix reference was backed with an actual mix design, which we could then check against the carbon and understand where we would be. They planned an actual pour volume, so how much did we say we were going to do versus how much did we actually have to do. Planned an actual carbon, so what did we plan, what did we say we were going to do was what we've actually achieved from the mix that we've poured, and then the total carbon at the end. So pour by pour, we could understand against our project target, against where we said we were going to be, how we were performing in concrete terms. And it was a really successful way of doing that process. And this is a pro forma that we now use across our projects to help us understand and track carbon across the construction stages. And it was really effective in terms of managing change and also maintaining our performance against the carbon budget. Next slide, please. Facades, we again do in a slightly different way. Engaging with the contractors early on is really important. There are new methodologies out now. So the CWCT's How to Calculate Embodied Carbon in Facades provides a really good kind of design basis. And that calculation methodology, which is kind of a sub-methodology under RICS, those do exist. So RICS doesn't cover everything. There are sub-methodologies in the industry that help you to do more detailed calculations of certain specific things. So we had already done the process that I've spoken to you about before. So not only had we talked about, what the carbon targets were, but those carbon targets were reflected in the documentation that was received back from the subcontractors. So they'd taken those targets, they understood what they needed to achieve. They then did their own calculations. And we're starting to see also bespoke EPDs. Facades are bespoke systems. They're not all the same. They're all quite different, in fact, in the different component makeup, different system typologies, different amounts of glazing to solid ratios. And therefore, having something like an EPD that you can use to cover facades, it doesn't work. A facade is a bespoke system on a building, and therefore it needs a bespoke approach, even at the design stages, hence the requirement for CWCT. What we're starting to see, though, is that actual EPDs are being produced for facade systems specific to buildings. So there is a way, obviously, of collating the materials, understanding the carbon impacts, and providing a project and system-specific EPD. And that's what we can see here for the facade system at 2 Aldermanbury Square from Shelterbow, where they broke all this down and provided us with the information. Of course, what we're trying to do is cover the main facade typologies. There are lots of different facade typologies on a building. If we go on to the next slide, we'll see the huge variety of different facade systems. You don't need to read through any of this table. It's just to give you an example of how many different facade types there are in this building. And therefore, we use the methodology of plus or minus. We've got one EPD that covers the main facade systems. Most of these other facade systems are variations on that facade typology to maintain the aesthetics of the facade. And therefore, you can plus or minus them. Some have different that aren't EPD, but are like calculated in the same methodology. But once you've got that EPD and you've validated the carbon emissions for each of those materials, it is possible then to use proxy calculations to calculate the rest of the facade typology. So we worked with them, bespoke, specific to the typologies on this building in the language that they required to help them understand the plus or minuses, where we needed an additional calculation because it was quite different, and where EPDs could be used cross-collaboratively to gather information for the facade. And that's a more bespoke way, specific to facades, again, of gathering information for construction and working in a language that they understand with the codes that are specific to their procurement and manufacturing. Next slide, please. Building services, right. Building services is by far the most problematic piece of information you can gather at construction stage. There are hundreds, if not thousands, of different materials within this. And there seems to be a feeling, I think, within the industry of too difficult, don't really want to gather that information. Where do I stop? You know, do I go down to hangers and bolts and nuts and connectors in ducts? Where do I start? How do I gather this information? And so often it gets kind of pushed to the back burner and you get all that information at a late stage. But the process of how you actually go through getting some of this information is exactly the same, right? You might have at the early stages an MEP package, and then that MEP package might split into 5 or 6 different elements. And you can see the kind of 7 elements that we've got here on 2 Old Manbury Square. So those are the kind of main key construction packages that we have. And we can then report them separately, and they can be assigned their trade contractors, in this case, T. Clark, Hotchkiss, Laurit, Hall & Kay, Kone. The next slide then shows the format of how this information is then captured. So working very heavily with T. Clark, we presented a pro forma whereby once those construction packages were known and the information in them was known, because we had that design information in a lot of detail in our kind of stage 4 construction model, you can see how those different things are kind of reported. And this is just kind of like the front screen, a track and record of information as and when it comes in to the overall whole life carbon assessment. For the next slide, we then needed kind of elemental packages, summary. So even within those construction packages, there are a plethora of different things and different parts that will be connected. And on the next slide, we can see all the different types of information. This is just an example of one of those packages that has 15, 20 different kind of sub-elements. And this was actually really quite important and innovative because we could track different parts of that package, see where the carbon emissions were, see how that information was gathered, and look at how complete that was, and also compare that against our design information. The last part of this on the next slide is the sub-tabs, right? The detail, the information that's being calculated and collected. So on the next slide, we can see just an example of that. And this just goes to show you that that information is there. It's available to be collected. This is not kind of like, you know, a thing where you just can't find that information and can't get it. The level of detail we got on 2 Old Manbury Square for MEP was extraordinary, but because it was set up in the right way, because they knew what we'd assumed at construction stage, and they could gather and do that information and gather that information the right way. And they knew we were speaking in construction. We weren't just saying, give us all the MEP information. We're talking about specific parts of specific packages, and gathering that information in that way was so important. And they engaged really heavily with this. The importance of engagement, I think, is really quite key. And on the next slide, what all this does from an educational term is that they start engaging with this information process. We start asking them for information like CIBSE TM65, which Paridi had talked about a little bit earlier on. The manufacturer then gains information. So they break down their component. Let's say you've got an air handling unit and you break it down into its component parts. They then assign carbon factors and then can understand how the carbon is distributed within that particular component. Is it in the fans? Is it in the casing of that system? From that, the manufacturer can explore opportunities to procure lower carbon products and materials that actually contribute to lower carbon. So you could turn around for the air handling unit and say, wow, 80% of the carbon in my air handling unit is in the steel casing. So therefore, is there an opportunity to procure lower carbon materials to reduce the embodied carbon of my product itself? So the feedback benefit of this is potentially huge, and we're actually physically seeing that in the market now. So on the next slide, there are some kind of examples of that. So the traditional position of there isn't enough data to engaging, doing a CIBSE TM65, and this is an example of kind of one of Mitsubishi's VRF outdoor units. And then exactly what I was saying, which is the AHUs from Swagon. They knew most of the carbon was in the casing of that AHU, and therefore they decided to go with electric arc furnace steel for that casing and reduced embodied carbon in a significant way. And ductwork is very similar. You know, typically galvanized steel ductwork is very, very common within the industry. What if that steel was electric arc furnace steel produced with, you know, low carbon electricity from a European plant? You can see the reductions that are potential there, and the engagement with this process is driving a level of learning and education that is helping actually to decarbonize the products themselves, and that's a fantastic thing to see. Next slide, which is my penultimate, is about overall engagement with that. So part of the problem with MEP kit is that taking lighting, or maybe even lifts for an example, with lighting, you might get an EPD for a lighting product, but there's 3,000 different lights within that range. So once you've done an EPD for one, you can develop a system where you can modify that EPD to provide carbon data back to the industry that covers the huge range of those types. And we did a big piece of work with Schindler where we were saying the lifts are bespoke to buildings, they're different typologies, they're different building heights. EPDs for lifts that you get out of one-click LCA only cover maybe 3 stories of height, a couple of doors. What if your building's 30 stories? How do you have a bespoke EPD for a lift system? So we work with them to produce what you can see on the right-hand side, which is like a customizable, these are the quantities of materials that are specific to X building, and therefore we could get a bespoke piece of kit or bespoke calculation that would give us the carbon emissions for that building. And actually what this has done is it's developed a sellable service for them, because they can do this calculation and then say to the client, well, if you wanted a formal EPD, third-party verified, you can pay for that and we'll get it done. So it's developed a system for them which is also commercial, as well as helping us to understand and interpret carbon for systems that are complex and different and, you know, change project to project, place to place. And then I think for my last slide is just a summary. So successful construction whole life carbon starts early. You can't start too early, I don't think. Getting those things in the back of stage 2 reports is even a great place to start, just to set out the overall intent of the scheme. Transferring models from design language to construction language. And I'll say that again, that's the most important thing that we do from going from design to construction. Tried and tested at SWECO for actually delivering on what we say. Trade-specific data collation methods help. A lot of that is soft engagement as well as hard engagement. Soft engagement, I mean, just getting out of your seat and talking to people, understanding how they do these things, how construction actually works, rather than trying to force RICS down their throat and saying, this is the only thing that you can possibly do. Getting to know how they procure, how they get that information is absolutely critical to getting successful inputs out at the end. And then engaging contractors and trades with that process does drive innovation, even in difficult parts of the carbon assessment like MEP. You know, don't be disheartened by people saying, oh, there's not enough information, there's not enough stuff out there. Ask the questions, put stuff forwards, learn to work with people in the way that they work, and that stuff starts to come out of the woodwork. And the more we do that, the better it will be for delivering low carbon products and low carbon buildings. Thank you very much for your time.
Thanks, Matt. Can you hear me? Yeah, good. Awesome. Very big depth and breadth of information. So thanks for that. I definitely learned a lot. We're going to go into the Q&A now. So I'm actually going to, again, because we're going for the Tandem House rules, so I will stop the recording